Hello.
And so, is
Yeah.
this is
So
is this website that you interview me or me interview you?
yeah. Okay. I think by default it seems that I'll be interviewing first. So let's go with that.
Okay. And
Yeah.
is this your first time using this website?
No. It's my second time.
Okay. It's my first time. If there is any mistake about like using this website, please give me a hint. Thanks.
Yeah. Sure.
So
Okay.
so in the normal interview process, usually the interviewer will describe the problem. Are you going to describe the problem, or let I just start thinking what I'm going to do?
Yeah. I missed your last moment. Sorry. Maybe just.
Okay, I'm going to grab some paper.
Can you just repeat? I missed. Yeah. Okay.
Okay,
So
so would you like to explain the problem, or I just do it directly?
sorry. I didn't get you.
Uh, Wait a moment. I plug in my earphone. Sorry,
Yeah, maybe the sound is not
not so clear.
proper. Yeah, yeah, sure.
Hello, is it clear? Okay, so the problem is you. So I just directly write the solution, or I will try to explain my thought first. Sorry, can you explain again because my signal is not very good. Mm-hmm. Okay, no problem. So I will. Okay, I think I will go to write the code, and at the same time, I will explain my thought. Okay. So my thought is this is the traditional matrix problem that only count 0 and 1 as the island. So in this problem, the problem wants us to count how much fully connected 1 is there. So I think my approach will be using the depth first search. And for example, if I can you see my mouse? Can you see my mouse? Okay, 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 okay. So I will just write the things in the editor. So like if there are 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, and this is uh, 4 row times 5 columns matrix. So I think my approach will be first traverse through each element in the matrix, and once I reach this one, I will stop the first search here and mark it as like maybe the other number, like say 2. So in the next time, like, so if the first search is implemented correctly, then this will be changed to 2. Okay, so I will count this as one island. And the next time, if I visit this island and it has been changed to 2, then it means the island has been visited, so I don't need to have to visit again. That will not duplicate my answer. And the same is true for this island and maybe this island. So this will give me the answer of 3. Okay, then I will maybe just start to coding the binary matrix. Let's say given the short name of BN. So the total number of row will be BN's size, and the column will be BN's row dot size. Is there? Oh no, I just checking there if there is a edge case, like there is no a matrix input, but the problem gives there will be definitely at least a 1 times 1 matrix. Okay. The DFS. Okay, then the DFS will be in the current row and current column. So if the current row and the matrix, so I paste the matrix here. And if the BN current row current column, if there's no if this element has been visited before, then I will just simply return. Else if check the for direction of the element. Sorry, my native language is not English, so there may be some strange accent. So I think I will just DFS the left, right, top, down, but there is need to do boundary checking too, otherwise I will get a segmentation fault. Or so I think I will pass total row and total column. So if the current row is less than or equal to 0, or current row is greater than or equal to the row, just simply return, and DFS the here means the right. The right means we are going to increment the current column by 1. And the matrix. Say 2 or 0, because we cannot visit it. Oops. Is there anything problem with your camera? I can't I can't see you now. Okay. Is your camera okay? Because a few seconds ago, I can see you. Can you see me? Sorry, maybe I have to check my settings. Do you use Chrome? Chrome browser? Yes, my Chrome has been set to camera and microphone are allowed. So can you see my face? But you can see my code. Oh, so maybe I will just describe the code. row, column, binary matrix. Right, up, left, down. So up will be row -1, left will be column -1, down will be row +1. So the number of islands will be, before that we have to make the visit matrix become 2. One. So 4. Maybe 0 will be better. Current color equals to 0. Current column is then the total columns, and oops, there's a typo. Then if binary matrix has not been visited before, so let's say the only legal element will be 1. Then we just DFS it. Let's see if I missed something. Else. Just continue. And return the answer. Legal. Yeah, so maybe given a self-defined test case. So let's say maybe the binary matrix is equal to I'll just use push. Because you want just to check the logic and thought of how do I solve this problem. So I will just press run test. Okay. Human. Okay, maybe I will just check for like 1 more minute if there is any typo or compilation error. So the row is size, the column is size, and current row, column. If the binary match current row current column is a legal element to do DFS, then we just simply do the DFS. So in here we do DFS. I think maybe I'll just give a small self-checking. Current row, if current row, go to the row. Oops. If the row is 0, it is still okay for traverse. But the -1 is not illegal, so simply return the row. But due to the 1 base and 0 base, the row is 1 base, but current row is 0 base, so the total row, if it equals to the maximum row, it will get a segmentation fault. Current row, if it's 2, mark as 2, as traverse say 2. So simply goes to right, up, and left, and down. After the function return, that will become 2. Okay, go to the run test. Run test. Oh, there. Read-only variable is not assigned. Oh, it's constant. So maybe I need to. I cannot change the value. Maybe I will just pass to another matrix. Say, I use like a sort of backup matrix, but it is not constant, so I can modify the value in it. bn const has to bn move up. Yeah, run test again. bn oops, maybe another tuple. Oh yeah, maybe yes. This is the order. Okay. Input 1, expected 1, actual undefined. Maybe I'll check where my problem will be. Like some edge cases, test if they will be good. Okay, sure. So put 1, expected 1. If the input is 1 only, it will go here. However, column row. Expected 1. Right. Up. Let me think why the edge case failed. I think maybe it's not lies the problem in the size, because if the size is the problem, then the first one will also fail. So maybe the second one is now the BM00 equals to 1, so go in DFS, and once we get into the DFS, they are qualified, so will not return because we are still in the legal position. So BM current row, current column changed to 2, and now DFS current row, current column plus 1, column plus 1 is 1, so in the recursion it will call this again, and the column is 1 is greater than or equal to the overall column 1, so it will simply return. The same is true for this because it's less than 0. The same is true for this because less than 0. The same is true for this because it's greater than 1. Seems okay, but it does fail. This is edge case. Does this run code means that I can run my own input? I thought this can be like the lead code one that you can press some user-defined input. Row, column, row, column, row, row. Maybe I can do some like local debugging because I can use some standard output. So so cannot run code here. So let's say, but throughout my thought, it is only the problem about 0 or 1. Do you have any hint? Maybe some. Okay, maybe I'll just figure out myself again. Okay. So in this time, maybe is it allowed to use this platform? But like say, I will locally write a CPP in my Vim and do a local test because I want the standard output, so I can see how the code executes or traces. Okay, okay. So maybe just a moment, about 1 minute or 2 minutes or so. I will do some debugging. Column row, column. Sorry, my laptop is a bit laggy. Column row 001, regular one. Yeah, I see the problem. Okay, because like say, if the problem I think lies in, like say, the current row minus one, and once the current sorry, the current, can you see my cursor? The current row now is one. Oh no, sorry. Current row now is 0, and 0 minus 1 becomes minus 1. I think this is the error of the order in this checking, because we because the C++ checking is, it will evaluate the true value from the left to right. So once the current row is minus 1, and it will get segmentation fault just right here before we want to check if the position is legal in the matrix. So I think I will just move this to the front. And have a test to see if there is a component. Okay, then I will check maybe my local debugging is okay. Sorry, wait a moment. I want to verify if this is true. Okay, let's see if it works. Okay, all passed. So if this interview passed, so usually in this platform, what are we going to do the next? Okay, sure. In this problem, I use the depth first search, and the runtime complexity, I think in the worst case, say all the elements are marked as 1, the runtime complexity of this problem will be O, say, row times the column of the matrix. So the upper bound of this algorithm will be O, time complexity will be O column times row times column. And for the space complexity, if we count the binary matrix as if we count the problem input of this problem, the space complexity will be O row times the column. And if we not count the matrix and we just use some auxiliary, like say pointers or say some, oh sorry, I want to say it again, sorry, there's some mistake. The space complexity I use here is also O row times column because I use an auxiliary matrix to copy the non-modifiable constant matrix to my own modifiable matrix, such that I can modify the number from 1 to 2 to mark some element as traversed before. So both of the time complexity, space and the time will be O row times column. Yes. Okay, sure. Also, you're sorry. So the problem you want to ask is how to change the depth first search uh, from the recursive one to the. I think I will use the data structure of stack because the set stack is the last one first out data structure. So once I push the say I will push push the the location of this element in here, and once I visit this one, I will check. I will use a for loop to check the maybe not for maybe just like this up, down, left, and right. If this is a legal point to traverse, I will push to the stack, and otherwise I won't push. So after I finish this this node or element, I will just pop it out, and I will pop this out, which is the next one. I will visit it, and if this one is in the boundary place, then next time here, can you see the problem? I can because my cursor is on the problem. Sorry. Maybe I will reuse this example. I think I will reuse this example. So I will talk again. If we want to use the iterative DFS solution, then first we will push, say in here. First, once we meet a legal element to do DFS, we will push this element to the stack. And while the stack is not empty, we will check its neighbor, like say left push, left, right, up, and down. If the neighbor is legal to visit to the stack, push to the stack. And so the next thing on the top of the stack will be this. So say the stack top is this one. Then again, because the stack now is not empty, so it will visit this one and push the neighbor, which is this one, right into the stack and visit it. The visit means we will change the current row to the and current column. I think I will use the stack of the pair. The pair can be described as the pair to represent the row and column of the element in the stack. So once we push out, that means we visit this one. And finally, this has been changed to 2. This has been changed to 2. So there is no legal neighbor to be pushed in stack. So because once we visit some element, we first pop it out. So now the stack is empty. Then we finished visiting this island here. So we iterated through the matrix, and here, and finally this one. And this one is very simple because it only has one element to visit. So we simply push into the stack, and once we are the step push the first element to the stack, and while the stack is not empty, we pop it out. And this is our current position. And we push the left, right, up, down to the stack if the neighbor is legal to visit, but none of the neighbor is legal to visit. So all of them are 0, and the right is out of boundary, so the stack will be empty, and the iterative solution will go to end. And finally, we meet this one, and the same is true for as this one. So we will just push this into the stack while stack is not empty. We pop it out, means the current position we visit, and we push the neighbor, but none of them is legal to visit. So the iterative solution will terminate, and thus increase the answer. Like this is the iterative solution. So the roles. So maybe this time I interview you. Okay, that's cool. It's my first time using this platform. Sorry, okay.